Let's talk about domain and range. Okay, we have functions, okay? And based on definition, a function is a relationship between independent variable and your dependent variable. In short, there is what we call an input variable and there would also be an output variable. So here, let's say for example we have this. Let's say here we have your ordered pairs. Let's say 1, 7. We have 2, 3. We have 4, negative 1. And we have, let's say here, 5, 0. Okay. So, when we are talking about functions, as what I mentioned to you earlier, that functions, the values of your first element, particularly your input variable, your elements for your x shouldn't be repeated. Okay. So from our example here, this is an example of a function. This is a function because as you can see, our x values are unique with each other. They are not repeated. Okay. So now, if we are going to identify the domain and range of this particular set of ordered pairs, your domain refers to your set of x values, okay? X values. Then you also have your range. This talks about the set of y values. In short, domain, this is simply talking about your first element or elements. I should here first elements, then we have your second elements, okay? Second elements. If we are using your ordered pair. So here, by looking at our example, we have here now, we have your domain. Your domain, we have here your 1, 2, 4, and 5 because they are the first or the set of first elements in our given set. Okay, so you should not be mistaken about the difference between your range and your domain. Your domain is simply the set of all x values, the set of all independent variables. Then here our range would basically be, we have your range. So we have here your 7, your 3, negative 1, and 0. Now let us identify all your domain. So here, our domain, we have, in our example, we have 1, 2, 4, and 5. So these are all our domain. Then our range, of course, by simply picking out your y values, we have now 7, 3, negative 1, and 0. Okay. So it's really easy to determine your domain and range, particularly if there is a given set of ordered pairs and identifying whether it's a function or not a function. You are just going to concentrate looking at your first elements. If it's repeated, then it will never become a function. It is simply a relation. Another example. So let's have another example. Let's say here I am going to give 0, 3. Then we have negative 1, 3. Then we have 0, 5, 0, 5. Then we have 7, negative 7. Okay. Question. Is this a function or a relation? What do you think? Okay, so here, to identify whether it's a function or a relation, you simply just have to concentrate looking at your given uh, x values. Okay, so let's try to look at this one. We have 0, we have negative 1, then there's again another 0, and we have 7. And getting into the definition of a function, your x values shouldn't be repeated. And in our second example, your 0 is repeated twice. Therefore, this is not a function. This is simply a relation, class. This is a relation. Okay? Because 0 is repeated twice. There should only be one values, unique values for your first element or your x values. Okay? Another. Let's say we have here this one. 1, negative 1, 2, negative 1, 5, negative 1, and we have negative 4, negative 1. How about our third example? Is this a function or a relation? Again, you just have to concentrate looking at your first elements, your values of x. Okay? So here, we are going to determine whether are there values of your x which are repeated. Okay, let us try to identify. We have your first value of our x, we have 1. Then followed by 2, followed by 5, and followed by negative 4. Do we have any of the different values or of x which are repeated in our example? No, they are not repeated. Therefore, this is a function. Okay? This is a function. Now, if it is a function, of course, we are going to identify our domain. Okay? Again, our domain, we have the set of the first values of, you know, your first element in the given ordered pairs. So we have 1, we have 2, we have 5, and we have negative 4. Then our range, we have your y values or your second element in the given set. We have here negative 1. If you notice, negative 1. It's just okay that, let's say, your y values are repeated, because by definition, if we are going to see the distinction of a relation and a function, we are simply going to focus on looking at your x values, which are the first elements in a given set of ordered pairs. Okay? It shouldn't be repeated. If it's repeated, then we call it a relation, not a function. And take note, class. Okay? Functions are relations. Okay? Functions are relations. However, relations relations are not functions. So always consider this. Okay? Thank you.